All right, another LeetCode medium, the top K frequent elements. And this question was asked by a lot of people the past 6 months, according to LeetCode. Facebook, Amazon, Apple, Microsoft, Google, Bloomberg, quite a few heavy hitters. And it follows the current pattern we're evaluating, which is the top K elements. So we're doing top K frequent elements, where you typically have to use a heap to solve these problems. Now here's a statement: given an array of integers r and an integer k, return the k most frequent elements. So here k is 2. From this array, they're asking us to return the two most frequent elements. So 5 and 14, 14 and 14 occur twice. So they take the cake. And you want to note that you can return the answer in any order. We want the single most frequent elements in this second example. The single most frequent element out of this array, which turns out to be 1. So we return 1. And that's all there is to this. And we have the solution. So in this case, we have this array of numbers, and we want the three most frequent elements from this array. So we're going to create a hash map that stores the elements and their respective frequencies as key value pairs. A minimum heap that keeps track of the top k frequencies. So in this case, k is 3, so we want a minimum heap of size 3. Now for 11, 11 occurs twice. 1 occurs once, 3 one time. 12 occurs 3 times. So 1, 2, 3. 5 occurs twice. And we keep that in a hash map. And then what we do is we insert tuples. So the value, the frequency, and the number, because this thing wants the number at the end of the day. So 2, 11. We do it 3 times. We put it again. This is a minimum heap, so the smallest frequency is on top. And we keep track of every time the heap goes beyond 3. So now we added 12 and 3 and 12. And the heap is now more than 3. So what do? We pop from the heap to keep it at 3. And we keep doing that. We add the next thing, 2, 5. We notice that the heap is now larger than 3 elements in size. And we repop the top element from the minimum heap, which is the least frequent element so far for this batch. And when we're done looping through the hash map, we can take everything, we take everything out of the heap to return the top k elements, which in this case are 5, 11, and 12. Looking at it with code and hopping back and forth with the solution might make things a bit clearer, so let's do just that. So we have the code right here, and first thing you want to do is create your map, the hash map with key value pairs, the frequency map. Loop through the entire array. If it's already in the array, if you've seen this before, set that particular element key. For instance, if you've seen 11 before, set 11 to what it was plus 1. So increment what was there. Otherwise, just set it to 1. You're seeing it for the first time. And this is a fairly standard operation in quite a few problems. You want to familiarize yourself with this. Moving on, we define a heap, the top k elements, and our minimum heap. So the minimum heap, the heap property is that the smallest value is at the root. And up next, so I think we're at this point pretty much. We've defined everything here. This is our map. This is our heap. Now we would go through all elements of the map and push them into the heap, which will have k frequent numbers. If the heap size is more than k, we remove the smallest number. We pop the smallest number. If the size is bigger than k, we check the size of the heap. If it's ever bigger than k, pop it. Loop through everything, every entry in the map. We remember we are storing the number itself and its frequency. So 11 shows up twice. 11 is the key, 2 is the value. So the number and the frequency for each one, we put them into the heap like so, into frequency number pairs. And we also check, oh, I just put something into the heap. Did the heap become bigger than k? That's what this is asking. Then kick something out. Just kick one element out. And when we're done through that entire operation, we've gone through everything here. we want to return a list of numbers at the end of the day, and not their frequencies. We don't really need their frequencies, but the heap has their frequencies. So we loop through everything while there's still anything in the heap, while the size is bigger than 0. We create this container array and push everything one by one from the minimum heap. And we only want the second thing, because remember we stored them as frequency first, number second, or frequency at position 0, number at position 1. So we take what's at position 1, add it to the array, and return. C'est fini. That's all there is to this problem. Let's look at the time complexity. So let n be the number of elements in our list and k the number of frequent elements we need to return. Since we iterate through a list of size n, inserting an element into the heap takes O log of k time, O log of k time, the standard. If k is less than n, the time complexity will be O of n times log k. However, if k is equal to n, the time complexity will be O of n times log of n, O of n log n, pretty much. And the space complexity, so we're using a heap and a hash map. The heap stores at most k elements, and the hash map will contain n elements. So the total space complexity is O of n plus k. Still linear, but slightly more than O of n. That's all. See you next time.